Hi, and welcome to the Pro 2003 Material Selection and Design. So for the week number one, we're going to have Introduction to the Material Selection and Design. So the materials in design. Now everything is made of something, of course. And as our understanding of the materials grows, so too does the technology advance and civilization evolves. So this reflected in our naming of the early time periods of the mankind. For example, we have what we call the Stone Age, which is 3.3 million to 5,000 years ago. Also, we have the Bronze Age, which lasted between 5,000 years ago and 1,200 BC. We had the Iron Age, which is 1000 BC, 1200 BC to 500 BC. And we had the Silicon Age, which is what we call the modern time. The connection between the materials and the mankind is a very old one. So you can have an examples about the evolve of the eggs during the different ages. So you can see that the Stone Age eggs was made of stone, basically has been sharpened to be a sharp edge, can be used for cutting. In the Bronze Age era, they start to have the bronze to make the eggs age, which is going to make it a little more flexible, harder, and easier to shape rather than the stone one. When they discovered the iron weapons and the cutting tools became very popular. They are stronger, but require harder manufacturing processes, higher temperature to get melt. Still, the advantages was worth it. The modern day axe actually is made of some composite materials or different alloys that make it harder, stronger, and most of the time is going to be rust resist. The solving of the challenges of the future will pose new material selection challenges. As what you can see here, you can see that we can have polymers. We can have silicon like the one we had in the solar panels. The carbon fiber or the fiberglass is used to make the car bodies, or for example, the plates for the wind turbines. The hydrogen is a different material. It actually is known, but is in use since the last century. It was used, as everybody heard, in the airship, which is something like what you call the floating balloon that carry people. It was using the hydrogen for a long time as a replacement for the helium until they had the accident in 1930s and they had to stop the Hindenburg programs. So solving challenges of the future, as we mentioned once again, require to have new materials. Like now, most of the old submarines are submersible, like the one we have in this one. The difference between both is that submersible is always going to have a connection to the surface. So the submersible that we have in this diagram was made of two different materials, which was titanium on one side and carbon fiber on the other side. And that was actually one of the reasons that caused a tragedy that we have few years back when it collapsed under the water and caused for the sudden, sad death of the people beneath. So a new solution isn't always required or even appropriate. So this subject is aimed to developing the skills and the knowledge necessary to select the appropriate materials for a given engineering application. Students should expect to first expand their knowledge of the material and the material science. Also, to develop research skills associated with the investigating of the material or materials or issues related to the materials. Also, to develop skills for systematically solving the materials related problems. The subject learning outcomes will include the analysis of the environmental issues associated with the potential use of the material in design solution. Also, identify the material properties that are relevant to a specific technical problems. The third subject learning outcomes is apply a systematic approach towards the selection of the materials for a given scenario. Fourth, provide a material selection recommendations with the appropriate justification. Fifth, apply a collaborative skills in the team setting to address the technical problems. And finally, appropriately communicate methodology, analysis, and the outcomes of the material selection process in the range of the different verbal and written formats. So some basic subject information is about the lecturer and the tutor at the Western Sydney Uni City campus. So the lecturer and the tutor is going to be myself, Ahmed Al-Zubaydi. You can have my email and contact. Many of you is going to be able to see me face to face weekly at least twice. So if you would like to have any consultation, simply send me an email or you can ask me directly during the class time. The program convener is Dr. Peter Landrum. Again, if you have any problem that is going to be out of my authority range, then simply you can contact Peter and he will solve the problem for us. You can find all the information about the subject available on the view, where you can find the subject outline, which is going to have some of the items we are going to cover next. This subject consists of two scheduled learning activities. First, we're going to have the lectures that's running for 2 hours every Tuesday from 8:30 till 10:30 a.m. It's focused on the specific themes relating to the materials. Also outlines the fundamental topics which students will need to become familiar with. The city center, the city campus lectures are on campus, and the lecture also will be recorded. The tutorials is going to be followed in the next 2 hours between 10:30 a.m. till 12:30 a.m. p.m. Well, that's p.m. It's conducted in the style of the workshop. The focus on developing skills in addition to reinforcing the specific knowledge. Students are going to be encouraged to participate collaboratively, and the assessments are going to be delivered and submitted during the tutorials. All the tutorials are going to be on campus and face-to-face. Both sessions are going to have a compulsory attendance. The learning activity will go through over a 14 weeks time. We don't have a semester break. That's means we're going to start in the first week on the 3rd of March. We're starting the week. The first session is going to be on the 4th of March. And we're going to continue with covering the material, the topic that actually mentioned in this table. The tutorial will start from the week number 2. We're going to have multiple submissions, like the quiz is going to be due in week 4 or 5. This will be subject to change according to your ability to do the quiz. Also, we're going to have the report, which is going to be submitted in the week 8. And finally, we're going to have the report and the presentation for the final report to be due in the week 13. So for the competency quiz, which is going to be having the weight of 30%, the student must demonstrate a competency with the Garanta CES education pack and the Scopus. A mandatory assessment with a threshold. It must be attempted and passed by 50%. It should be complete in week number 5, and this will be an individual work. Also, we have the material suitability report, which is going to carry the weight of 30%, where the student must conduct an investigation into the application of the material in specific applications. It should be completed in week 9, and also is going to be an individual work. The hypothetical design problem, which is going to be a report and presentation, which is going to be weight 25% for the report and 15% for the presentation. That make the total load of 40%, where the student must conduct a material selection process. It should be completed in week 14, and the group with individual components is going to be the load we are going to have. Note that the assessment weighing is going to be due to dates are available in the review for the review in the VUE University of Sydney. So the critical subject resources we have is the Granta CES Education Pack, where access remotely via the VMware Horizon and Intel can be found on the VUE. Also, it can be accessed directly from the computer lab. The Scopus can be accessed via the Western Sydney Uni Library. The textbook we're going to have is going to be Ashby, the material selection in the mechanical design, and also the Callister and Ritwich for the material science and the engineering, the 10th edition. So by that we finish the questions. We are going to have we can ask some questions during the first session about the subject and about the assignments and other technical issue we may have. Now we will go for the next section of this video, which is going to be about the introduction for the materials. So we start with the engineering design process. Finding a solution to a problem is highly specific to the context of the situation, but a process is always going to be followed. In general, the process follows a several steps or stages, like there's a problem. So we need to specify the problem, and we need to specify the solution. So the after we specify the problem, we're going to spend time for formulating a potential solution. Then the most promising of the potential solutions are going to be rationalized for an actual realization. Step number 4 is if a solution can be found, then attempts are made to release it. If the solution is successful, the process ends. If not, the process returns to step 2 and then iterate. While there are many formalized ways to conduct the design process, they all share the above basic steps, and we will focus on what the considered the engineering design process we should follow. So these points can be simply represented by a schematic flowchart. So what we need is a market need. What are design requirements? This will be the start point. So we're going to go through the concept design, the implement design, the details, and then we're going to go to the product specifications. When we're going to have the product specification, we can simply send a feedback for every single step that we had earlier to find the final solution or the final product specification to prepare it for the production stage. So once again, the flowchart also can be simplified as the following. First, start with the conceptual design. So we are going to define the problem, gather information, concept generation, evaluation of the concept. That's what we call the conceptual design. So from here, we always can get to find the evaluation of the concept to be done, and then we can send the feedback to update the previous steps. If passed, we can simply go to the product architecture, where we're going to have the arrangement of the physical element modularity to be done. Then we're going to have the configuration design, the parametric design, and the detailed design, which is going to have the final stage, preparing the engineering drawings, and finalize the PDS. So we'll start with the key phase 1 about the conceptual design. So the first step is going to be establish a customer, user, or the market needs. And these needs to be captured and expressed in a form that can be efficiently communicated with the design team. Then we go to the problem definition, where we need to develop a problem statement that will satisfy the needs of the customer if accomplished satisfactorily. This will include the identification of design requirements. Then we need to do the gathering informations. This will be done by review and analysis the available information resources. And these can be patents, competing products, research literature, codes, and regulations. Then we're going to have the conceptualizations, where we develop a suite of the potential solutions using the team-based creativity methods such as the brainstorming. Then we're going to have the concept selection, when we need to evaluate the potential solutions to yield a preferred or leading concept. Several decision-making approaches are available for the objectivity, selecting one or two concept forms a large pool of concepts. Then finally we go to design review, where the outcomes of the conceptual design phase will be reviewed and evaluated before committing resources to the next phase. So here we represent how the concept design can be influenced by how the problem is defined. So you can see that we have multiple scenarios, like the first picture at the top left corner is about as proposed by the project sponsor. In the middle, again to see as specified by the project request. And the third one is going to be as designed by the senior designer. We're coming to the second row, we can see that the first one from the left is going to be as produced by the manufacturing. The one in the middle as installed at the user site. And finally, what the user actually wanted. So if you would like to follow the steps, we should send from the last one, what the user actually wanted. So we are going to avoid all the complication we are going to have if we are going to go to the wrong direction. So the key phase 2 is about the input elements design. So we need to remind the product architecture. We're concerned with the arrangements of the product systems and subsystems and or the modules to ensure that the physical components of the design can work together as required. Also, the configuration design of the parts and the components, where we need to have the identification of the component features, like the holes, ribs, etc., and the arrangement relative to the other parts. Materials and manufacturing processes are considered. The parametric design of the part provide appreciates dimensions and tolerances for the parts and the components. Also provide the final decisions of the materials and the manufacturing. Design robustness if evaluated upon the assembling the respective parts, contributing to the prediction of the failure. Key phase 3 is detailed design. So the details engineering drawing is going to be the first step, are going to be developed to a standard applicable for manufacturing. Also, verification testing is going to be completed and all critical to quality parameters are going to be confirmed. Assembly drawings and the instructions are completed, including the bills of the materials. Then details costing estimates, which is determined and decision made regarding to the internal or external supply of the components. Finally, the design review, which undertaken to confirm the product can proceed to manufacturing. So the engineering design process, you can see that we should start with the market need, where we're going to have design requirement. Then we're going to go with these different steps from the concept, the implements, and the detail design. And we're going to have the product specifications. So the material selection can be conceptualized as a consideration of 4 interrelated considerations. First is the function. How the components must perform usually going to be constrained to some extent. Second, the shape, where the geometry and the weight often constrained but not always. The materials suggested a consideration of function and shape, and the process on how the components manufactured to obtain the required geometry, assure the functionality from a suggested material. The cost and sustainability are additional influences which are going to be typically evaluated once the material, function, shape, and the process are going to be conceptualized. Now we can extend the previous flowchart. So once again, we said that we are going to start with the concept, the impedance, and the details. So we start with each one. We need to feed them with the design tool, like the function modeling, the availability studies, the approximate analysis, geometric modeling, the simulations, methods, the material selectors, the process selectors, the cost modeling, and finite element analysis, modeling, and design for X. Now for the material data needs are going to be data for all the materials, low precision and details. Data for the subsets of the materials, higher precision and details, and data for one material, higher precision and details is going to be also submitted. So the concept 1 is going to be polymer, concept 2, for example, is going to be metal, concept 3 is going to be ceramic, extra, and extra. For the concept 2, we're going to use the metal. For example, we're going to make a comparison between the aluminium with the steel, with the titanium, and other materials. The concept number 2 is going to be a metal using the titanium. What will be the grade, the timber, the source, and extra. So just a problem example about the design of the robot dog. So we start with the technical system. We're going to check about the sub-assemblies, the products we're going to, the components we're going to make, sub-assembly 2 and sub-assembly 3. We're going to decide what will be different components that are going to make different sub-assemblies to find the final products to be assembled. So we need once again to put the inputs, which are going to be the energy, materials, and the information, to run the multiple functions in the technical system. For the technical system can have subsystems within, like the function 1 to function 6 we can see within these boxes. And after we're going to have desired functions, which is going to be the output. So by the end of this topic, we can simply summarize that you should do the following. First, know the aim and the purpose of the completing this subject. Second, know how this subject will be delivered, including the schedule of the assessments. Also, know the learning outcomes associated with the subjects. Finally, know where to locate the relevant information and resources associated with this subject. It is also hoped that you are developing a sense of curiosity regarding the materials, how they can be used, and how they are going to be selected. Reading from this topic can be coming from the chapter number 1 from the HBA textbook, and also it's going to be chapter number 1 from the G. Editor and L.C. Schmidt book, the Engineering Design 5th edition. So that's it for week number 1. We're going to see you next week, and we're going to have more interesting things to be taught to you. Thank you very much for watching, and see you soon.